Hi, I'm Tracy with Legacy Woodworking Machinery. Congratulations on purchasing your Legacy Revo ornamental mill. Now, without wasting any time, let's go ahead and get your boxes open and get the machine put together so you can start making sawdust. You're going to find several hardware packages in the boxes that you'll use during the assembly process. There's one that is labeled spare hardware. The purpose for this kit is if you're missing a screw or a washer in one of the other kits, you can simply get into this bag and continue with the assembly process. You're going to start with the frame hardware kit and the kit labeled tools. You'll start by building two of these end frame assemblies, and they will be mirror images of each other. Note that in the frame hardware kit you have two different lengths of the cap screws. You'll use 4 of the shorter cap screws in these 4 holes here, and 2 of the longer cap screws to mount the angle plate. Now you'll find 2 end panels that are exactly the same. You'll find a left and a right foot, a left and a right table mounting bracket, and a left and a right angle plate. Now place a star washer on each of the 4 shorter cap screws. Mount the table mounting bracket on these 2 holes using 2 of the short cap screws, and the foot on this side using the other 2 short cap screws. Now we'll go ahead and tighten these 4 cap screws in place. For the next step, we'll place a flat washer on each of the 2 longer cap screws. Now we'll mount the angle plate. Notice that the foot has a curved relief for the angle plate to slide on. Now put the 2 cap screws in and then tighten them up with your fingers. Just finger tight. Then we'll flip this over and we'll place a jam nut on this top screw. Now you'll have the 2 mirror images of the end panels. If this cap screw here is loosened, you should be able to adjust the bed plate, the angle plate, like so. And then we'll go ahead and tighten it down in place. Now if you look at these parts, you'll notice the orientation of all of the components. The 3 flanges are all pointed up. Now we can just set these 2 assemblies aside for a moment. Let's grab a couple of rails and lay out on the table. Now you want to pay close attention to the orientation of the rail. If you look in this slot, you'll notice that on one side it has a groove. On the other side, it's smooth. You want to start with the smooth side up, as shown here. Next, we're going to take 4 of the locking plates, and we're going to insert them into the end of the extrusion. Notice that there's PEM hardware that's pressed into one side of the plate. That PEM hardware should be down inside the groove, as shown here. We'll slide 2 into each rail. Now you'll position 2 of the locking plates at each end in approximately 8 inches from the ends. Let's take one of the end plates now, and the flanges will go towards the outside of the machine, and simply place that into the extrusion. Now you'll position this bracket so that it's 9 inches from the end of the extrusion. Again, this inside face of this bracket right here should be 9 inches from this end. Once you have it in place, we'll use the cap screw with the star washer. Now we'll go ahead and tighten this bracket in place. Then we'll do the same thing for this side. Inside of this bracket should be 9 inches from the end of the extrusion. Using a cap screw and a locking washer or star washer, we'll go ahead and tighten that in place as well. Now we'll do the same thing at the opposite end here. When you tighten these down, you can go ahead and make them extremely tight, because these will never move again once it's put together. Now we've got the frame assembled. Let's just set this aside for a moment. We'll grab the other two rails, and you'll need the hardware kit labeled bed hardware. Once again, you'll want to pay close attention to the groove inside the slot. We'll want the side with the groove down. Next, we'll take the locking plates. Again, it has hardware just on one side. We'll put that hardware down and insert it into the slot. We'll put 2 into each rail. Now in this hardware kit you have 2 sizes of screws. We're going to use the 4 longer screws for this first star washer on the longer screw. This kit has 2 of these U-channels, and we'll assemble each one exactly the same way. You'll have 4 of the tabbed locking plates. Flip this U-channel over and then insert 2 of the locking tabbed plates right through this slot here. And you can see how they just rest on those slots. Now we'll take this bracket and just set it on top of the extrusions, like this. Now we'll take the long cap screw with the locking washer and just insert it through this hole and drop it down in and thread it into the locking plate. Now we'll put the second screw in on this side and tighten that down into the locking plate. Actually, at this point, you'll want to loosen those up just slightly so that you can slide the bracket back and forth. Insert the 2 plates into this bracket and repeat the same at this opposite end. Now with these 2 parts loose so that we can adjust them, we're ready to attach this assembly to the frame. And we'll just flip this over. Now I'll come around to the front side to assemble the bed. There are 2 remaining cap screws from the bed hardware kit. So we'll put a star washer on each one, followed up by the flat washer. The cap screw with the washers are going to come through from the back side in this slot right here and go into the hardware in the channel. So we'll take this assembly, stand it up on front of the frame, and then insert this from the back side. Again, this bracket here can be adjusted or slid into position. So we'll line it up with that slot and then take the cap screw and bring it through from the back side. Now we can adjust this bed up and down. Temporarily, I'm going to adjust it so the top of the U-channel here is even with the top of this bracket. So we'll just slide it up into position and then clamp it in place. Repeat this step for the opposite end, bringing the top of that U-channel to the top of this bracket here. And lock it in place. This is the front of the machine, and on the left-hand side right here will be your headstock. So it's important that this end of the machine is all flush. All of these extrusions are the same position. We've already got the top two locked in place, so we use a straight edge. We'll just use the rail for the carriage and line it up with the ends of these two, and then we'll slide this extrusion up until it's just even. With this top bed rail positioned even with the end of the top rails, we can go ahead and insert the driver from the back and tighten the cap screw that goes into this top rail to lock it in place. Now I'm going to tighten the cap screw at this end as well on that top rail, but it might be easiest to see it if we flip this around. Now we also need to adjust this bottom rail here so that it's flush with the end. So once we get it into position, we'll need to tighten it, but we'll need to raise the bed in order to get access to that hole. So I'll loosen this cap screw here and raise the bed up like so. We'll do the same thing at this end. We'll just raise it all the way to the top and lock it in place. We'll position a straight edge right here to make sure that these two rails are flush. Now we'll come down to this end and tighten that bottom rail here as well. Now we'll go ahead and just flip this around. For this next step, we're going to use the lead screw and the hardware kit labeled X-axis drive hardware. This hardware kit has two of these brackets, however we'll build each one up differently. To start with, we'll take two of the bushings and they insert into the hole from the inside of the bracket. Then you'll take one of the flathead screws and put in through the bottom here. Take one of the jam nuts and thread it on from the outside. And we'll do the same step to this opposite side here. Now we'll tighten these in place. Now the second one is done a little differently. With the small hole down on the bottom, you want to position this on the outside on this end. And the flathead screw will go through from this side. And of course the nut is on the inside. Now we're going to use the two locking plates with the insert and the cap screws. Place a flat washer or a star washer on first, followed by a flat washer, and then the hardware will come from the inside out like this and thread into the locking plate. Now you can see that this PIM hardware is on the opposite side of the screw. Now repeat this on the second bracket, exactly the same. Now it's easiest to see this when we do it from the opposite side, so I'm going to turn the machine around again. It'll go here on the left side. Now at this end, we'll use the bracket with the two bushings in it. You want the screw down at the bottom, and it'll insert from this end. Now we'll make this end flush with the end of the rail right here and tighten that in place. The next step is to put the couplers onto the ends of the lead screw. The coupler has a mark right here, or a ring. It's thicker on one side than it is on the other side. The thick side is the part you want to put over the lead screw. And we'll want to make sure we line this set screw right here up right on top of one of the threads. So what we'll do is remove the set screw altogether. And we'll slide this on. So you'll thread this on until the screw comes through to that mark. Then we're going to twist the coupler until the hole lines up with the thread. Again, we've inserted the lead screw until it comes up to this mark right here, and then we twist it until that hole lines right up on top of one of the threads. And then we'll go ahead and put the set screw back in and lock it in place right there. Now that one's tightened down. We'll go ahead and flip this around and do the same thing for this end of the lead screw. This is a very snug fit. If it's too tight, you may want to take a file and just touch off the end of the screw. And once that hole is lined up with the thread again, then we'll go ahead and put the set screw back in and tighten it in place. Take the short support shaft and insert it into one end. Go ahead and tighten that in place. Now we've got this shaft on, we want to put a little lubricant on here. You can use a grease, or we'll use the Dynaglide to lubricate that end. Now I'm going to walk around to the back of the machine to insert this so that you can see what's going on. And we'll insert it into this end just to support it while we set up the other opposite end. Now we'll take the drive shaft that has the square end machined onto it, and again we'll apply a little Dynaglide to lubricate it. And then we'll insert this through the two bushings at this end. Now we'll tighten this down, and then you don't want any gap here, so we'll just push this forward till it's up against the bushing. Now we'll come down to the opposite end, take this bracket and slide it forward till it butts up against the collar, and then lock it in place. I'll flip this back around so we can work on the front of the machine again. And you're going to need the kit labeled head and tailstock hardware. Start by placing two of the locking plates in the rails, one in the top rail, one in the bottom rail. Again, the PIM hardware goes to the inside of the machine. Now the headstock has two holes in it right here, and the kit has the cap screws that are very long to reach through the headstock and then into the locking plate. With these two cap screws loose, we can still slide the headstock forward or backwards. We'll want to bring it up flush with the end of the rails right here, and then tighten them in place. With the headstock mounted in place, we'll attach the tailstock. Again, just put two locking plates, one in the top rail, one in the bottom, and use two of the long cap screws to go through the holes into the locking plates. Now, of course, the tailstock has to be able to slide, so we'll put it into position anywhere at this point and go ahead and just tighten this up. You're now ready to set up the gears and the pivot arm linkage. You'll find a grease packet with the gears, so you want to apply a little grease to the spindle shaft on the headstock here, and also to the drive shaft here. The pivot arm linkage also has a shaft in the center. We'll put a little grease on that as well. Now the large bushing will go onto the spindle shaft, and the smaller bushing here will go onto the drive shaft. For the next step, you'll need the package labeled spindle hardware. This is the knob that will hold the gear onto the end of the spindle shaft. We'll take the standard index gear, that's the one with the 24 holes in it, and put it on the end of the spindle shaft and lock it on place with the clamping knob. Next, we're going to take the duplex gear. It has the two gears that are bolted together, the 4 screws here. With the small gear on the back, we'll put that on the end of the machine first here. Now the small gear here has a plate on either side of it, and that'll act as a guide. So you'll put this large gear, the index gear, between the two plates to engage the gears like this. And then we can go ahead and lock this in place. The Revo comes with 3 drive gears, and to set it up, we're going to use the middle size gear. Slide these gears forward, and then place the middle size gear onto the end of the drive shaft. Now these gears will come back to engage. You can see right now that we're not properly aligned, so we'll need to make one adjustment to the position of the drive shaft right here. I'm going to turn the machine around to make it a little easier for you to see how to make this alignment. To make the adjustment, we'll start at the back end here and loosen the 2 screws that hold this support in place. We'll also loosen the 2 screws at the headstock end on this bracket here. That way we can slide this shaft forward and backwards. The next step, we'll put the drive gear onto the end of the spindle shaft. But before we do that, we'll need to get the hardware from the X-axis handle package and build up the drive handle. In this hardware package, you'll find these components to make the handle. We'll take the screw out of the end of the tapered handle here and put it through the round hole, and then we'll tighten that down. All right, once this handle is tight, we'll go ahead and take the drive gear, again this is the middle size drive gear, and position it on the end of the drive shaft here. Now in the kit, you'll also have a small spacer that'll go on after the gear, and then we'll put the handle on and lock it in place. Now we can go ahead and slide the entire drive shaft with the handle and the gear and everything either to the left or to the right to align it with these gears here. Once they're aligned correctly, we can go ahead and tighten this cap screw on the pivot arm, and now your gear should be fully aligned. Next, we'll go ahead and tighten the 2 cap screws on this bracket to secure it in place. At the tailstock end, we'll also need to slide this bracket up until it makes contact with the coupler, take out any slop, and then tighten these two cap screws as well. Once again, I'm going to turn the machine around as we continue the assembly. The next step is to assemble the carriage. You'll need the hardware package labeled Carriage Hardware. You will also need the carriage base plate and the two rails. Before you assemble the carriage, there's one step I would highly recommend that you take to ensure that the machine will operate very smoothly. All of the components for the Revo are machined to very high tolerances. However, the extrusion itself, we found, can vary approximately 6/1000ths of an inch, which is just enough to cause a little bit of drag. What you'll want to do is take the bushings from the kit, the round bushings, and insert them into the end of the extrusion like this. Once you put it into the extrusion, it should be able to slide fairly easily like you see here. If it doesn't, we'll want to take a file and touch up this diameter right here. Again, the side that you want to touch up is the larger diameter. Then just take a file and just run it around the diameter. And it won't take much. You can test it by simply taking that larger diameter and setting it into the extrusion into the slot, and then it should slide easily like this. Once it does, you can take that part, go ahead and slide it inside here, and know that it's going to operate correctly once we have it assembled. Now, most machines will never need to make this adjustment. However, occasionally there will be one that will be just slightly tighter than we would like. So again, just test that and make sure that it's going to slide easily in the extrusion before you make the assembly. To assemble the carriage, you'll need the two rails, the carriage base, the 4 locking plates, and 4 cap screws with star washers and flat washers. Start by putting the 4 locking plates into the extrusion. Remember that the PEM hardware needs to go down. And we'll line those up with these holes here approximately to start with. Now you notice these tabs are bent down, will go right into the extrusion. You'll also want to note the orientation of this slot right here. It's in the middle of the carriage, not down here on the end. Then slide the base forward or backwards until these tabs on this end right here are flush with the ends of the extrusion. Then you can go ahead and put the cap screw in and tighten these in place. For the next step, you'll need 4 more cap screws. This time, you will only use a star washer. No flat washer is required. Now take one of the glides and just place it under the carriage, and we'll put a cap screw down through this hole to secure it in place. Again, notice the orientation of this bushing. The small diameter is down and the large diameter is on the top against the carriage. Now go ahead and attach all 4 of the round glides. So you've got one in each corner of the carriage. Now we'll flip the carriage up and insert the glides into the ends of the extrusion on the top rails. Here you'll need 4 cap screws with both star washers and flat washers. Next, we're going to attach the glides to the router base. Notice on one side it has a hole, on the other side there is a slot. So the side that has the hole you can go ahead and tighten up. The side with the slot you'll want to leave just a little bit loose so that you can adjust it after you put it on the machine. So you can see this one can be adjusted after we put it onto the machine. Note the orientation of the glide bushing as well. The larger diameter is on the top, the smaller diameter on the bottom. On the router base you have 2 holes that you can use to mount the locking handle. It doesn't matter which side you put it on. I prefer mine on the right hand side, so I'll put it on here. The router base will slide onto the carriage like this. You'll need to align this locking plate and then just slide it on all the way on. At this point, we can go ahead and tighten these 2 down. For the stops to go on the X and Y axis, you'll have a cap screw, a large flange washer, and the stop itself. So put the screw through the washer like this, and then thread that into the stop. The stops can slide inside the side of the extrusion like this and be locked down here to limit the movement of the router, both forward and backwards. Now on the X-axis, which is along the length of the machine, we'll put the stops on the back side of the machine here, and that will limit the movement of the carriage left to right. The next step is to put the split nut on. Now the nut, when it fits onto the lead screw the very first time, is going to be extremely tight. Now when you slide the split nut in this slot and engage it onto the lead screw and lock that down, then as you crank the handle, it's going to move the carriage. The Legacy will accommodate several different routers. There are a few features that you want to keep in mind. First of all, you definitely need a plunge router. Some of the other features you might look out for are the micro adjust, the variable speed, a soft start, and of course we like to use the eliminator chuck. Currently, Legacy carries the eliminator chuck for the Bosch and Porter cable routers. Depending upon the router that you select, you may need to mount it differently on the machine. This router, as you can see, the handles are high enough that you can plunge it down with the handle straight forward. The Hitachi is the same, plenty of clearance. Now on this Bosch, if you mount it straight forward like this, and you plunge it down, the handles will interfere with the plates. So what we like to do on this particular router is to rotate it so that the handles will go down like so. Now I decided to mount this router turned to the right, and so I moved the knob over to the left side of the carriage like this. Now we'll go ahead and place the router onto the carriage and rotate it until the handle clears the rails. And then I'm going to take a pencil and just mark the straight edge on the back of this router here. Next, I can take the base off the router and line it up with this line that I've scribed, center it over the hole, and I can mark these 3 holes to drill for this particular router. After you drill those holes, you want to countersink them so you won't have any burrs around the edges. By mounting the router turned this direction, both the switch and the scale are right here in front. In the hardware kit for the template follower, you'll find the nylon screw and the machined block for the stylus. Start by threading that in, and then you have a couple of screws here, cap screws, that we'll use to attach this to the follower plate. Now there are several positions that you can put it on. To begin with, we're going to mount it on the very end of the plate. The template follower plate will now attach to the back of the router base here. You will need to remove the split nut in order to mount this in place. You also have 4 cap screws with washers that you'll use to mount this plate here on the back. This plate is slotted. We'll start by positioning it right in the center of the slot. That way you can later make adjustments to the position of the stylus if necessary. We'll go ahead and tighten these 4 cap screws in place. The template support bracket has a series of holes for mounting templates here, and then it has the hardware with the locking plates to attach it to the rail. It can either be attached to the inside of the rail or to the outside of the rail. We're going to attach it to the outside of the rail to start with. We'll just remove that stop and slide this on the end of the extrusion. Of course, this can be positioned anywhere along the length of the bed. Normally, we're working on stock between centers, so we're going to set it up at this end near the headstock. And we'll go ahead and tighten this in place. Now we'll apply the 2 tapes. You have one tape that goes on the y-axis, which is back and forth across, and one on the x-axis along the length. So for this first step, you'll want a centering tool, or if you don't have a centering tool, you can simply use a router bit that has a point, such as a V-groove bit or a point cutting round over. You want to have that center point there. Then what you'll want to do is make sure that you take your tailstock and tighten it down. Doesn't matter where it's at, just tighten it down onto the rails. Then we can plunge this bit down and line that point up with the dead center. Now with the tips lined up correctly, we'll just take a pencil and scribe a line on the inside of this rail right here, right on the front of the carriage. The easiest way to apply the tape is to remove the router and base. Then position 0 on the line and cut off the excess. Next, replace the router. The front edge of the base will indicate the position of the router relative to 0. To position the x-axis tape, it's easiest to mount a piece of stock with the hub on it. I'll just take this hub and mark some holes, or mark the position of the holes rather. This is hard maple, so I'll need to pre-drill it. I can't just run the screws into it. You'll notice I've also drilled a hole on this end for the tailstock. Now these two holes are to mount the hub. We'll just use a couple of 1-inch drywall screws or grabbers. And that's ready to go. Now we'll reposition the tailstock. Insert the hub into the drive center here and just slide your tailstock up until it supports the part. For right now, that'll hold it in place. And we're going to take the tip of our center finder or router bit with a point on it, and we're going to position it right at the end of the stock here. Now with the carriage properly positioned, we're going to mark the front of this rail right here. Now that mark will be our 0 in the x-axis. Now the easiest way to do this is to slide the carriage back a little bit and take the tape and simply slide it under the carriage here on the front. Now on this end of the tape, we'll peel back the backer about 1 foot and then apply it right there at the 0. Now with that first 1 foot stuck onto the rail, we'll simply slide the carriage over the top of that. Now we'll come down to this end and rip off the rest of the backer. And then apply that the full length. Now that the tapes are properly positioned, we can go ahead and add the Dynaglide, and that'll make it so the carriage will slide very nicely. The way the machine is set up now, you're ready to start cutting between centers like a lathe. There's one other option. We have the brackets that we can put a router table on here, so I'll show you how that goes on next. Now you have the option of either moving the tailstock just to the one end, or we can take it right off so that it's out of the way. Now in the kit for the table, you have 4 of these locking plates. Just put 2 in each rail. And again, the PIM hardware goes back inside the extrusion. Now you have 2 of these brackets to support the table, a left and a right. Right here on the top edge is a tab that's going to insert inside the slot of the extrusion. And just take one of the cap screws, it's a 1/4 cap screw, and put it into the locking plate. We'll go ahead and tighten this one up right here. And we'll take this one and put it on this side. Now this bracket can slide into position anywhere we want before we tighten it down. I've cut a tabletop. I made mine 10.5 inches wide, about 14 inches long. It of course can be as long as the entire machine. This is going to mount here on top of these brackets, so we'll want to adjust this spacing accordingly right here, and now we'll drill some holes to mount it to that bracket. Now we'll lay out the hole pattern on this table. From the front edge we're going to come back a 1/2 inch and then back to 7 inches. The spacing between the two holes is 6.5 inches. Same thing on this end, a 1/2 inch and it's 7. Now we'll just draw a couple lines across here. Next we're going to measure in from each end 1 inch. And that's where we'll drill the 4 holes to mount it to the brackets. Now drill these 4 holes out with a 7/32 drill bit, and then flip it over, and you'll want to countersink it for the flathead screws. Now this bracket's still a little loose, so we can make an adjustment if we need. We've got the 4 holes drilled and countersunk, so we'll just set them on top of the bracket, and then using the flathead machine screws that came with it, we'll just attach it to those brackets. Now we want to go ahead and tighten these brackets underneath. Now you can adjust this table up and down to accommodate different thicknesses of stock, so the carriage will go right over the top of it. We can either run the router over the stock, or we can position the router and feed stock through like a traditional router table.